Today, let's take a look at adding and subtracting rational expressions. In order to do that, let's do a quick recall. If you recall, when you had to add and subtract fractions, if you had 3/7 plus 2/7, if you remember, in order to add or subtract fractions, they must first of all have the same denominator. If the denominators are the same, we keep that denominator and we add or subtract the numerators. So if I add 3/7 plus 2/7, I get 5/7. If I had 2/9 plus 2/3, again, in order to add or subtract fractions, they must have the same denominator. So the LCD for 9 and 3 is 9. So I'm going to have two fractions with the same denominator of 9. Well, this numerator will remain the same because this denominator is already 9. But here, since I'm going to get a new denominator, I must get a new numerator. So let's go back and recall how we're going to get that new numerator. You ask yourself, 3 times what would give me 9? It would be 3. So 3 times 2 would give me 6, okay? Now that they have the same denominator, you keep the denominator and you add your numerators. So 2/9 plus 2/3 will give you 8/9 as an answer, just to refresh your memory. So we're going to be using that same concept as we add and subtract our rational numbers. We're going to start by, let's find the LCM. The LCM is also your least common denominator. So let's find the LCM of each pair of polynomials. And I'll be using prime factorization. So example 1. If I had 12x to the 4th, y to the 5th, and 32xy to the 2nd. Well, the first thing I'm going to do is do prime factorization. Remember, prime factorization is where I'm going to take this composite number 12, rewrite it as the product of prime factors. And as I do that, I will use exponents. So 12 would be 2 squared times 3. I'll keep these variables with their exponents. To get 32, I need 5 2's to get 32, so I have 2 to the 5th. Now to find my LCM, I'm going to write down all of my different factors, prime factors that I have one time, and we're going to treat the variables as though they're prime factors. So I see a 2, I see a 3, I see an x, and I see a y. And then I'll select the greatest exponent for each. Well, the greatest exponent for 2 is a 5. I only have 3 to the first. The greatest exponent for x is a 4. And the greatest exponent for y is a 5. And as I simplify, 2 to the 5th is 32. So I get 32 times 3, x to the 4th, y to the 5th. 32 times 3 gives me 96, so I get 96 x to the 4th, y to the 5th. Well, Mrs. J, what in the world does that mean? That means that if I ask you to add, 1 over 12 to the 4th, y to the 5th, and add to it, let's say, 3 over 32, x, y to the 2nd, your least common denominator would be 96x to the 4th, y to the 5th would be your least common denominator. So your LCM is also your least common denominator, right? Example 2. If I had x squared minus 3x minus 28, and I have x squared minus 8x plus 7, and I want to find the LCM. Well, these are trinomials, so the first thing I need to do is factor these trinomials. So when I factor the first trinomial, remember with your factoring, ask yourself, are there two numbers I can multiply and get a negative 28, combine and get a negative 3? And those would be a negative 7 and a positive 4. On that second one, I need two numbers I can multiply and get a positive 7, combine and get a negative 8. Well, in order to get a positive 7, I will either multiply two positives or two negatives. Since the 8 is negative, both of these factors need to be negative, so I would have a negative 7 and a negative 1. So to find my least LCM, again, which is also going to be my least common denominator, I'm going to write down my different factors. I have an x minus 7. I have an x plus 4. And I have an x minus 1. And the greatest exponent for each one of those binomials is to the first power. So that is your LCM. So I just wanted to teach you how to find LCM, which is also your least common denominator, as we get ready to add and subtract these rational expressions. So let's find each sum or difference. And this will be example 3. If I had 8x divided by 6 plus 5x divided by 6. Again, we can add or subtract fractions if they have the same denominator. These have the same denominator of 6, so I'm going to bring that denominator of 6 over. Add my numerators. 8x and 5x are like terms. Add the numerical coefficients. 8 plus 5 is 13, so you get 13x. We do not write any mixed numbers, so your answer is 13x divided by 6. Example 4. If I had 3y divided by 3 plus y, and I want to add to that y squared over 3 plus y. Again, they have the same denominator of 3 plus y, so I'll bring that denominator over. Add my numerators, I get 3y plus y squared. Well, if you notice in my numerator, 3y and y squared have a GCF of y, so I'm going to factor out y. And when I factor out a y, I end up with 3 plus y. If you notice, I can cancel the binomial 3 plus y, cancel that, and I have an answer of y as an answer. Example 5. I had 2x plus 4 over x plus 1, and I'm going to subtract 5 plus x over x plus 1. Well, they have the same denominator of x plus 1, so I'm just going to write that denominator just one time. I'm going to subtract my numerator, so I have a 2x plus 4. You're subtracting this, and this happens to be an expression, so I would advise you to do minus and put that in parentheses so that you won't mess up. So let's clear those parentheses. So I get a 2x plus 4. Remember, when you have a dash before the parentheses, take the opposite of what's inside. The opposite of 5 is a negative 5. The opposite of a positive 1x is a negative 1x. Now, as I simplify, combining like terms, 2x minus 1x gives me x. 4 minus 5 gives me a negative 1. These are not the same. I can't cancel out these x's, those 1's. My answer is x minus 1 over x plus 1. Example 6. If I had 17x plus 4, and it's divided by 15x minus 5, minus 2x minus 6 over 15x minus 5. Well, again, these have the same denominator, and what I'm going to do is, in my denominator, 15 and 5 have a GCF of 5, so I'm going to factor that denominator right quick. So I'll get 5 times, inside parentheses, I'll have a 3x minus 1. In my numerator, I have 17x plus 4 minus this expression, and again, I'm going to write it in that form so we won't mess up. So I get 17x plus 4. The opposite of 2x is a negative 2x. The opposite of a negative 6 is a positive 6. As I simplify, 17x minus 2x gives me 15x. 4 plus 6 gives me 10. And in my numerator, 15 and 10 have a GCF of 5. So I'm going to factor out a 5, and I get a 5 times. 5 goes into 15, 3, so I get a 3x, and 5 goes into 10, 2. If you notice, I can cancel out these 5s. That gives me a simplified answer of 3x. That should be a plus 2 over 3x minus 1. Example 7. If I had n squared over n minus 3 plus 3 over 3 minus n. If you recall, n minus 3 and 3 minus 1, 3 minus n are opposites. So I'm going to take the n minus 3 to be my LCD. So as I look at this denominator is already n minus 3, so that means that numerator will remain the same. But when I divide this denominator into this LCD, because they're opposites, I get a negative 1. Multiply the negative 1 times the 3, I get minus 3. This cannot be factored, so my answer is n squared minus 3 over n minus 3. Example 8, if I had x plus 3 over x plus x minus 5 over x plus 1. Well, my least common denominator for my only two factors are x and x plus 1. They don't have anything in common, so my LCD for this problem is x times x plus 1. So I'm going to write this with my one denominator. Now I'm going to find my new numerators. I'm going to divide x into this denominator. X goes into this that many times, so that will cancel. I'm left with this, so I take the x plus 1 up here and multiply times the x plus 3. So it's x plus 3 times x plus 1. Plus, when I divide this into this, that goes into that time, so I'll take the x and multiply times the x minus 5. As I multiply, when you multiply these two binomials, you get an x squared. Remember, that's 1x, that's 3x. Combined, you get 4x. 3 times 1 gives you 3. That gives you an x squared minus 5x. That is over that denominator. As we look at this, as we simplify, x squared plus x squared gives us 2x squared. Then I have a positive 4x and a negative 5x, which gives me a negative 1x. I don't have anything at all to combine with that 3. And if you check, you won't be able to factor this. So this is your final answer, is 2x squared minus x plus 3 over x times x plus 1. Example 8. Trying to give you enough examples. If I had x plus example 8. If I had x minus 3 over x squared minus x minus 20, and I want to add to it x over x plus 4. Well, I need to find my least common denominator. So let's factor this x squared minus x minus 20. Let's see if we can think of two numbers we could multiply and get a negative 20, combine, get a negative 1. It would be a x minus 5 and an x plus 4. This is already x plus 4. So when I find my LCD, I'm going to write down my different factors. My different factors are x plus 4, x minus 5, and the greatest exponent for each is the first power. So my LCD for this problem is the binomial x plus 4 times the binomial x minus 5, okay? Now I'm going to write this factored form down here. Okay, so when I divide this denominator into my LCD, it goes 1 time. So 1 times this numerator will give me x minus 3. When I divide this denominator into this LCD, I'll end up with x minus 5. So I'll take that x minus 5 and multiply it by x. As I simplify, I get x minus 3 plus x times x is x squared. X times a negative 5 is a negative 5x over that denominator. As I simplify, I have x squared. X minus 5x is a negative 4x minus that 3. And I can't think of two numbers I can multiply, get a negative 3, combine, get a negative 4. So that is my final answer. One last example. Example 9. If I had 2 over x minus 1 plus 3 over x plus 1 minus 4x minus 2 over x squared minus 1. Well, let's look at this x squared minus 1. X squared minus 1, remember, it's the difference of two squares. So that means my LCD, I have an x minus 1 here, an x plus 1 here. So this is my LCD for this particular problem. So my least common denominator is the binomial x minus 1 times the binomial x plus 1. As I divide this denominator into my LCD, I'll be left with the x plus 1. So I'll multiply 2 times x plus 1. When I divide this denominator into this LCD, I'll be left with x minus 1. So I'll have plus 3 times x minus 1. And this denominator is exactly this LCD. That's subtraction, so I'll do minus so that we won't mess up on our sign. I'll write it like that. This is equal to, I get a 2x plus 2 plus 3x minus 3. The opposite of 4x is negative 4x. The opposite of a negative 2 is a positive 2. That's over my LCD. As I simplify, I see 2x plus 3x, which is 5x, and 5x minus 4x gives us 1x. I see 2 minus 3, which is a negative 1, and a negative 1 plus 2 gives you a positive 1. That is over this denominator. As I cancel, when I cancel this, I'll have a 1 in my numerator. So my answer is 1 over x minus 1.